Hi everyone. I've recently developed this program that I thought I'd share with you guys. So a very common thing that I've wanted to do when I'm developing firmware for a Arduino or really any microcontroller or even FPGA is to visualize data, of course, especially if you're working with sensors. I do some robotic stuff and it can be really helpful. And so I thought I would share this program and I would show you how to use it. And it's also free and open source, so I'll show you how the code is laid out as well. So this first demo I've got right here, I have my little balancing robot off screen. And you can kind of see here we have live data coming from the, we have the accelerometer up here, and we have the gyroscope readings over here. I have the calculated pitch, which is, if it's if the robot's leaning over or falling backward here. I have the magnetometer readings over here, although they have not been calibrated, so they're way out. And then I have some statistics down at the bottom. And so, yeah, once again, basically, if I lean the robot up, we can see we now have the pitch of around, actually, there you go, around 0, it's right here. And if, when it falls back, it's more like that. And so we can kind of see how the accelerometer and the gyroscopes also kind of react accordingly. Anyway, so that's one. And then I know that a lot of my viewers use Arduinos, and so I wanted to show kind of a very simple, basic Arduino project as well. So here I have a little Arduino Uno clone, and I have 3 things plugged into it. I have a light sensor, I have a potentiometer, and then I have a thermistor. And so on the top graph we have the light sensor, which is kind of hidden right here. And if I cover it up, we can kind of see it respond when you walk light out, or if you don't. And in the middle we have the potentiometer, and so if I rotate the potentiometer, we can see it respond accordingly. And this particular potentiometer has detents in it, so that's kind of why it looks a little choppy, because it is. And then finally at the bottom I have a thermistor, and if I put my finger on it and heat it up, you can kind of see that voltage reading drop, and then if I take my finger off, it will climb back up. So I'm going to show how to write the code for the Arduino, and then how to use the program, and then finally I'll explain how the program is laid out, so that if you know how to program in Java, you can kind of poke through it and make changes if you want. It's all open source. Alright, so here we are at the computer. I want to start by writing the code for the Arduino, so go ahead and bring up the Arduino IDE. And what you can do is you go to File, you can go to Examples, Basics, Analog Read Serial. And we're going to modify this. So I'll go ahead and type it all out, and then I will explain what it all means. Okay, so at the beginning of the video I showed you guys the Arduino, and you might recall that we had a light sensor, a potentiometer, and a thermistor attached to it. So I'm reading those measurements here, and then I want to put that into a single piece of text. So I created a C string, or a character array called text. I just made it size 40 because you need it to be big enough, but 40 is actually bigger than we need. And then we use sprintf to basically printf into that string, and you tell it which string you want to write into, and then your format string, which is that's kind of the important part. %d means to write out a number. The d is for decimal, and so you write out a number, and then you have a comma, you write out another number, you have a comma, you write out another number, and then you have a new line character, which is like pressing enter. And then these 3 numbers correspond to the 3 variables here, which we read over here. And so my light sensor is sensor 1, and it is connected to pin A0. My potentiometer is sensor 2 and it's connected to pin A1, and then my thermistor is sensor 3 and I have it connected to pin A4. Now, one thing you don't normally need to do is this part. Because I have my thermistor already mounted on a little 3-pin device, I'm actually going to use a couple pins, A3 and A5, to power the thermistor. So I'm using A3 and I'm driving it high, which is basically providing 5 volts. And I'm using pin A5 and I'm driving it low, and that's providing ground. So I basically, the thermistor and a resistor form a voltage divider, and that's why you need 5 volts and ground. But yeah, for your circuit, you probably won't need to do that part. Just do whatever you need to do for your particular circuit. But yeah, you'll need to modify, put all your measurements here, and then if you have more than 3, add another comma and another %d, and then you'd put whatever here, whatever you have, whatever else you have there. So that's about it. It's actually really simple. You can see it's, 10, 20 lines of code. Go ahead and verify it, and it will compile. And then we can go ahead and I'm going to go ahead and upload it to the Arduino. Alright, so we see down here that it is done uploading. And if you go ahead and open up the serial monitor, we will see we now have our text. So you can see it's just streaming in live. We're getting a ton of values. That first number again is my light sensor. So if I move my hand in front of it, we'll see that it'll get a smaller number. If I move my hand away, it'll get bigger. That middle number is my potentiometer. I'm going to go ahead and turn the potentiometer, and you'll see that it will go between 0 and 1023. And then this third number is the thermistor, and again, if I touch it and heat it up with my hand, you'll see that number slowly drop, and if I let go, now it'll come back up. So this is the part you've got to make sure you get right. You need to have your numbers. They need to have just the number and then a comma and then a number and a comma and a number, and that's it. So don't have any other information printed out. Don't have any spaces or anything like that. You don't need just a number, a comma, a number, a comma. So it's called a CSV, which is comma separated values. That's what you're doing here. Okay, so that's really all there is for the Arduino. You can see it's really easy, not much going on. And so if I then open up the program, so this is the program that I have a link to down in the video description, and it's a jar file. You'll need to have Java installed. Alright, if you just search for Java, and that's not what I wanted. There we go. Here's Java. And if you go to the download link, just click here and then download and install Java. You probably already have it installed, but if you don't, you will need Java 8. So make sure you get Java 8. An older version probably will not work. Okay, so yeah, it's a jar file that I have a link down to in the video description, and if you just double click it, it'll pop right up. And so I'll kind of explain how it all works. I'll cover these a little bit later. Let's start here in the bottom right. So sample rate is how frequently your Arduino is sending data to the computer. And so if we go back to the Arduino sketch, we have a loop, and then we're delaying for 10 milliseconds. So in theory, we're basically executing this every, or 100 times per second, because there's 1,000 milliseconds per second. Now it's a little bit slower than that because we're wasting some time, not wasting, but we're using some time in the code here, but it's roughly 100 times per second. So we can type in 100 here, and you'll see why that might be useful later on. You don't actually have to type in a number here. It isn't critical. So for the communication types, we're using CSVs. It's very easy. There's also going to be a binary mode that I plan, although I think I'm going to comment that out in the code that I share, because it's kind of broken right now, and it's harder to use anyway. So always use ASCII CSVs. Those are the comma separated values we went through earlier. and then pick whatever COM port you want to use. My Arduino is on COM 8, and then whatever baud rate. So I left it at the default of 9600, so I'm going to use 9600, and then click connect. Alright, we're connected to the Arduino. We now need to tell it what those comma separated values are. And so the first value, which is column number 0, that would be basically the first number here, which I have as sensor 1, which I have as my light sensor. So you give it a name, you can pick a color if you want. I'm going to go ahead and leave it as red. And you can give it a unit. It isn't calibrated, I'm not going to type in a unit, but if you had one you could. And you could also do a conversion ratio here, which I'll cover in just a second. And then you click add. And so we've defined what column 0 is. We'll go ahead and define column 1, which is our second column, which is right here, sensor 2, which happens to be a potentiometer. And we can give it another color. And this one I'm going to go ahead and scale it. So I want it to be shown in volts, and we know the Arduino has a 10-bit ADC, which means the maximum reading will be 1023, and I have a 5-volt Arduino. So basically we're telling it that could take the number and convert it so that, with a full scale of 1023, turn that into 5 volts. And you click add, and you kind of see here is what that all does. And then finally we have the thermistor. And I'll go ahead and pick the color for that, and I'm not going to try to calibrate it into degrees, so we'll leave that alone. We're not going to do any scaling, and there you go. And you click done. Alright, so we have defined the data structure, and we're now ready to visualize all of our awesome data. So if you just click and drag anywhere in this grid area, so click and then drag and then let go. And now you can tell it what you want to put in that region that we just specified. So you can do, we have a couple different, or about 5 different charts. The first one, which is the one you saw earlier, is the time domain chart cached. And duration is basically how many samples you want to see at a time. So this will show us the 1000 most recent. And then we can choose to graph one or more values. So if I click add chart, we'll see here we have the chart, and I moved my hand in front of the sensor, and you can see that it just kind of jumps all over the place. So there you have it. The cached version will auto scale, and it will scale both the top and the bottom number to kind of fit everything. And as you can see, when all this stuff goes away, you'll see all the noise where you're jumping up and down by 1 or 2. If I move my hand in front of it again, there you go. And let's take a look at the other graph type. So if I click and drag over here, the time domain chart, the regular one, do the same exact thing. So it looks pretty similar. You can see that it will auto scale the top to be roughly identical here, but it has the bottom. It'll always be around 0. It doesn't. It won't. Do that. And if I move my hand in front of it, you can see we get all that motion. Okay, so the cached one, which is here on the left, I wrote that because it'll let you, if you ever want to chart a large amount of data, like tens, hundreds of thousands of points, use the cached chart, because it actually it slices up the chart into 32 pixel wide strips, and it actually caches them. It keeps the old data. So you can kind of see how all this data is just kind of scrolling by, and instead of rendering all of it, it will just render the new stuff, and it will save the old. Anyway, so for an Arduino or for many things, you don't need to do that, but if you ever want to cache a lot of data, you'll find that this type of chart will take a lot of processing power, a lot. Whereas the cached one, you can do a whole lot more. Okay, so let's look at a few more types of charts. We can do a frequency domain chart, and again we have how many samples to look at and what we want to look at. And this is doing a Fourier transform. And this is the only chart where the sample rate down here actually matters. So if this value is not correct, then the frequency measurements down here will be incorrect. And let's see if I can... I'm going to move my finger in front of the sensor approximately once per second. You can kind of see it's not really a clear sinusoid, so you're not going to get a good measurement. But you can kind of see we have a peak right here around 2, about 2 seconds, or 2 hertz, so every half second. And then we have harmonics and mainly noise. But this would be useful for like audio applications or stuff like that. But right now we're kind of down in the noise. You can do a histogram, which is really useful. So right now we have just a few values and there's only a few bars. I'm going to go ahead and try to create a nice little variety here. There we go. So it's really more useful for measuring like maybe a voltage rail or anything. You can kind of get a feel for the distribution. But yeah, that's another useful chart. And if we look down here at the grid size, by default it's 8 by 8, and so it's 8 columns and then 8 rows, and you can make that bigger. So I'm going to go ahead and make it 12 by 12, and by compiled in at at compile time, 12 by 12 is the biggest that I have currently set. Although you could change that code if you want. And then finally we have statistics. So we can take a look at what is the minimum reading, the maximum, the mean, the standard deviation, all that we have down here. Alright, so those are kind of the various graph types. So that was really all kind of boring. I'm only showing one thing at a time. We can certainly do a lot more than that. So if you want to, you could graph all 3 together, and then let's see, I'll turn the potentiometer. Well, actually, this is one thing that I forgot. Okay, so an important thing to keep in mind is when you graph multiple things, they should all have the same scale. And of course, I'm scaling the potentiometer, but I'm not scaling the, they have different scales. So the potentiometer is in volts, and the others are just in the ADC readings. So that actually doesn't look very good. Let's see. The light sensor and thermistor are not scaled, and that should look better. Okay, so here we can see if I move my hand in front of the light sensor, and then if I put my hand on the thermistor, you can see that kind of jumping up and then back, or down and then back up. Okay, so but yeah, it doesn't really make sense to graph those together because they're totally unrelated. But you might want to do sensor measurements like an accelerometer altogether or gyroscope altogether, like you saw at the beginning. And yeah, so for some of the charts you can graph multiple things at once, which would be the time domain charts. The others are only one at a time, so you just pick from the drop down box. And that's pretty much it. It's really easy to use, and yeah. Down here, the reset button, if you click that, it will just get rid of all your charts, and then you can add a chart back in. You can save the layout. So I'll just do, I'll call it quick test. Okay, I just noticed that my screen recording software cut out. I'm going to go ahead and bring the software back up. I'm going to go ahead and reconnect, and then we'll pick back up. Okay, so yeah, we'll go ahead and create some charts again, and we'll do a few different types. Okay, so we can save the layout, and I'll go ahead and put it on the desktop, and I'm going to call it quick test. So quick test and then save it. And then now if we want to kind of restore this, you can at a later point in time open up the program, go to Open Layout, and go to that file. It'll take a couple seconds to connect, and there we go. So here we are, we have the data, and I'll go ahead and move my hand in front of the sensor again. We can see it's all working live. Alright, so yeah, it's really easy to work with. In fact, let me show you. So if I go to Open Layout, and I have the one that you saw at the very beginning of the video, my balancing robot, and I'll go ahead and connect to that. Now that robot has a Bluetooth serial module, and that takes about 5 seconds to connect to, so that'll take a little longer. But yeah, here we go, we're back in. So yeah, really useful, especially for when you have more complex things like this, where you have multiple graphs open and you might have different settings for each of them. And if you pick up the robot, you can see that it's all working. It's live. Okay, great. So I hope you find this software useful. There's a link in the description down below to both the jar file, which you can run if you just want to use the software, and also the source code if you want to poke around and play with it. Now the second half of this video, which will be starting right now, I'm going to go ahead and cover that source code and kind of walk you through where everything will be located. So if you don't want to program in Java, or if you don't really care about the source code, you can stop here. Hope you enjoyed the video, and share it with anybody that you think might benefit. Okay, so those of us that want to play with the code, there will be a link down in the description below for a GitHub repo. And I'll kind of show how it's all organized. So it's called Telemetry Viewer, and we have a whole bunch of classes right here. It all starts in main.java, and basically in main, I tell Java to use the system look and feel. So in other words, in Windows, make it look like a Windows program. And then I create a main object, and then in the main object, I just create a window. And then in that window we have a charts region, which would be the bulk of the area that we're looking at here. It's kind of where the grid was. And we have a controls region, which is the little panel at the bottom with all these buttons all the way down here. This is the controls region. And then I just stick them in the window. I stick the charts in the middle, the controls at the bottom. I make the window maximized and blah blah blah. So it's all pretty standard. I'm not going to go into too much detail. So let's take a look at the charts region. Again, that's the bulk of the window. That's where the grid is, where all the charts are, and it manages the grid size, and when you're clicking and dragging to place a new chart, it stores those grid locations in there. And it'll register some event handlers, so it'll be notified when if the user types in a new grid size over here, the chart region will be notified of that change. Yeah, let's not go into too much detail, otherwise it's going to be an hour-long video. If we go to the controls region, same thing, we have a whole bunch of buttons and we populate them, and we have event handlers. So I'll go through one of them, like the Open Layout button, which is right here. We create the button, we add a event listener, or an action listener as they call it, and so if the user clicks on the button, we create a file chooser, and if the user picked a file, we then get that path, and then we call a open layout method in the controller, which I'll get to in a little bit. And so the rest of the buttons are similar. They do similar things, and there is fault checking. So if you try to set a grid size of, I don't know, A, it won't crash, hopefully. And so that's the controls region. So I have the whole program organized as a model view controller. So the model contains the data. So that's where kind of some hard-coded stuff is located, and where we save state. And then we have our data structure definitions are defined in here, and that also contains the actual samples from the Arduino or whatever microcontroller, or even an FPGA if you want. And then we have the charts. And then the middleman between the data, which is in the model, and the GUI, which is what you're looking at, is the controller, and that's where all of the logic is. So basically, the code for the GUI handles just the GUI parts for the most part, and then the controller handles all the logic, and the model is all the data. And it's a big file. It's probably 900, yeah, a little under 900 lines of code. I could have broken it apart, but I didn't. And so at the top we have things related to the grid, and then we have things related to the data sets, which would be you know, your data structure definition, and then all the samples that go along with it. And then we have our serial port methods to open and close and to receive data. We have our chart listener stuff where we can notify code if a new chart has been added or if a chart has been removed. Sample rate, default line color, sample count. So yeah, I don't want to go into too much detail, but yeah, it's all there. If you have any questions, of course, feel free to ask. I'm happy to answer. I just don't want to waste too much time and bore everybody. Okay, so let me show you. So if I remove all these charts, go to reset. So when you click and drag, when you let go, we have this window pop up called Add New Chart. If we look here, we have a new chart window, which is that window. It's this. And so basically, it lays it out on a JPanel, and it queries the controller to figure out what possible chart types we have, and then depending on what chart type you picked, it'll know a valid range for the duration. Currently, they all let you have a really wide range, but some things you may only want to have one sample of. In the future, I plan to add some of those. Anyway, and then we have, for charts that can take multiple inputs, we have checkboxes, and for charts that only take one input, you have a drop-down box. And all that logic is in here. Alright, and so then when you actually add a chart, all charts are a positioned chart, and it's basically a JPanel. And all it does really is it's a JPanel, and it'll manage the resizing and testing to see if an area is occupied. So if I create a chart, so if I resize the window, that chart resizes accordingly, as you would expect, and that is what the position chart does for you, kind of behind the scenes. And then that region occupied code right here is so that if you want to create a new chart, you can't overlap. So it's smart enough to limit you like that. And then we have the various chart types. So time domain chart cached is the one that you guys saw the most of, and it's right here, and all the codes in here. This is really kind of an overly complicated one because I really optimized it to reduce CPU usage. The regular time domain chart, which would be these two, they work great for small data sets, but when you start wanting to graph 100,000 lines of, or 100,000 points, or a million points, it slows to a crawl. Even on a modern i7 running at 4 gigahertz, it can't keep up. Whereas the chart one, or the cached version that I wrote, it can handle very large data sets and still be very quick, because as you can see, the line chart is kind of scrolling by, and there's no need to re-render the old data. You only need to render the new data. So I save it all as strips of pixels. And anyway, so long story short, it's really complex and convoluted, but it's much more efficient. And then we have time domain chart, which are these two. and that uses the JFree chart library, and most of the work is being done in get time domain chart. We have statistics chart, which is this guy right here, and it's basically a J table, and then I update that table. Yeah, so there you go. I update that table live, and so we have. I'm using the Apache Math library, the Apache Commons Math library, to do the statistics, and basically I calculate them all here, and then I have Swing update the GUI with the new data. Okay, so let's get going before this gets too long of a video. We have the histogram chart, which we saw earlier, and it's also based off of the JFree chart library, and the majority of the work is happening here. And yeah, you can kind of read through that and check out the documentation for JFree chart to go into details, or ask me and I'll answer if I can. Frequency domain chart is a Fourier transform, and it's a line chart based off of the JFree chart library. I calculate the Fourier transform here. I didn't actually use a FFT, I just did a simple, easy to understand DFT. I'll have to optimize that later on, but it works. What next? So the data set is, when you define the data structure, each one of those CSV columns is a data set, and that contains all the information you entered, and also the actual samples that came in from the Arduino or whatever microcontroller. So the CSV column number is here. The binary processor is not used yet. That's for future use with a binary packet. The column name, column color, the unit, and the conversion factor is all right here that we saw earlier. And basically, we have a few methods to access elements or samples that were stored, or to check how many samples we have, and then to access the ones we have, to add new ones, or to clear the samples. This I optimized to be thread safe without any locks, so that helped speed things up a lot. And to do that, though, when you clear the data set, it doesn't actually free any memory. I need to add some more code before I can do that without risking a null pointer exception. But in any case, with an Arduino, you're not really sending a whole lot of data very fast. So even if you leave it running overnight, you're not going to use a whole lot of memory. And that's pretty much it. So the listener classes they're actually interfaces. So for example, the serial port listener, the controls region down here needs to know if we lose connection, or if we gain a or if the connection succeeds. So it will register a serial port listener, and then the controller will notify it accordingly. And same with the grid changed, the chart listener, and chart descriptor. The binary processor isn't used yet. That's part of the binary packet mode that I have commented out because it isn't really functional yet. Anyway, so there you go. That's kind of all the code. I'm happy to go into detail if you have any questions, but I don't want to record a really long video and scare people away. So yeah, there we have it. Once again, the program is free and open source, and I hope you guys enjoyed the program and the video. If you have any questions or comments, please leave them down below. And if you liked the video, please share it with anybody that you think might benefit from it.